Yeah. Okay, so this is my. Just a second. Yeah. Okay, so this is my first stream, and let me tell you what is the purpose of this channel. Okay, so in this channel, um, we all will try to cultivate a habit of showing up every day, a habit of doing the things you love, a habit of doing productive things instead of doom scrolling, and yeah, basically, uh, this is another come study with me challenge. Come study with me stream. Come study with me streams, and yeah, uh, I've seen multiple people stream uh, their progress or anything, and I guess it uh, motivates or it motivates other people who are like average people, just like me, just like everyone else, to become good at something and be successful in life. So from now onwards, we will try to be as consistent as possible in doing the things we love. You may pause me, or you may, mute my voice and just work along with me. Isn't it? It's I guess a good habit, I guess. And yes, the skill which I'm aiming for is competitive programming, and I will be solving some questions from core forces. I will be solving some questions from competitive programming theory book. I've been coding for like an year or so, and I have developed an interest in the CP thing. So yes, I hope that we will enjoy this journey, and let's just make a cult. Let's just make a group where everyone motivates each other, where everyone tries to be as productive as possible, and for as just I guess um, I don't know if I will be doing this, but uh, I will be streaming, but I don't know if I would turn on any sort of music instead of study music or not. I will be just sitting here uh, in complete silence, trying to work on the thing which I love, and I guess you all will do it with me. Anything, man, you can study for your exams. Yeah, anything. You'll try to study as long as possible. I may take some breaks in between if I have to. Uh, any short break if I'm tired. Yeah, yeah. So I guess let me check if I'm live. Yes, I'm live. So yeah, let's begin with this journey. So actually, I'm solving. I'm reading chapter 3. It was page number 98. Yeah, I'm not a complete beginner in programming, but I am relatively weak. Yes, our hope is to become as good as possible. Okay, so I was reading this question. Okay, iterate to complete search subsets UVA 12455 bars. Let's just open this question. Um, yeah. Okay, so let's read the question together. The question is bars. Some things grow if you put them together. There are some metallic bars. There's known length. There are known lengths. There. Why am I'm stuttering? I'm really sorry. And it's necessary. We want to solder them, some of them, in order to obtain another one being exactly a given length long. No bar can be cut up. Is it possible? Okay. Input. The first line of the input contains an integer t, indicating the number of test cases. For each test case, three lines appear. The first one contains a number n, representing the length of the bar we want to obtain. The second line contains a number p, representing the number of bars we have. Third line of each test case contains p numbers representing the length of the p bars. Output for each test case, the output should contain a single line consisting of the string yes or the string no, depending on whether the solution is possible or not. Okay. Uh, I guess it's a good habit to, read the test cases first. Okay, so what is the first line? The first line is, um, yeah, the first line is the number of test cases. The first line contains the number n, representing the length of the bar. Okay, we have to create a bar of length 25, and we have four bars. We have the following um, 10, 12, 5, and 7. So we have to somehow solder its bars together and get a bar of length 25. So let's break it down in mathematical terms. What do we actually mean by soldering? Soldering can mean addition, right? Right. Let's say I first solder bars of length 10 and 12. That means I will be getting a bar of length 22, and so it's just the addition of these two numbers. So uh, we have to find a subset. Yeah. Uh, Actually, it's given subsets. It was given in the book, but it's pretty easy to spot that we have to find a subset whose length is 25. First of all, let's get back into VS Code. Oh, the question number is 12455. Okay, initially we won't write any of this and we will just focus on the questions. So we have to somehow generate what's the brute force we can think of. We have to generate all the subsets possible, and we have to check if if I can make a bar of the given length or not. And basically we have to just yeah basically we have to just print true or false. So even if we get single uh, bar of, let's say, length, what is asked, then it's good to go. We don't have to uh, you know care about the actual elements which are being selected. So let's see how we can do this. We will not go through the solution first, and we will just try to understand what is going on. So, is there any mention of the bars, the length of the bars are not duplicate? No, 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 I don't think so. The second line B going to represent the length of the B bars. Okay, so we have to, so it is not given that there are, the lengths of the given bars are distinct. And yeah, as we can see in this case. Interesting, isn't it? Okay, first of all, we will try to print all these um, subsets. Yeah. So what do you actually mean by subset? Okay, it is a bunch of decisions which we are making. Let's say we have to create a subset of this array, which consists of the numbers 10, 12, 5, and 7. So we can either select an array. By selection, I mean we can either include it in our subset or we can exclude it. That is it. So let's say I want to take 10. in my subarray, in my subset. Yeah. So I can take 10. I don't want to take 12. I don't want to take 5. And yeah, I want to take 7. So the resultant, now we don't have any more decisions to make. So the resultant array which we have created is actually the subset of the array n, 12, 5, and 7. And the subset is n and 7. Now we can either not take any of the elements at all, or we can take all of the elements. Yeah, yeah. This is basic math theory. And what are the subsets? Let's say we'll take smaller array. Mm, what are the subsets of 13 and 55, 67? So the subsets are 13, a null set, only 567, or 13 and 567. So now that we have the idea of what subset is, let's just get into our code. Okay, so void generate subsets. Vector int arr, vector int subset, and int ind. Ind represents uh, the element which we have to decide if we have to if we have to include it into a subset or exclude it. Okay, so we can either take it include it in a subarray and then go on with our lives subset, yeah, ind plus 1. We have to now um, select for the next index, or we can exclude it, pop back, and you know, go on with our lives again and select for the next index. Now when will this now when this recursive function stop? It will stop when the ind is pointing at arr size, that is, represents that we are at the end of the array and we can't make any more decisions, and will simply print all the elements of the subset. Make sure that you return after printing. And yes, I guess we are good to go. Vector int arr. Let's take 1 to 3. Vector int subset, yeah. Generate subsets, arr subset, and obviously ind should be 0 as we have to take a decision for the first element of the array as well. Let's hope that this function prints all these subarrays. Yeah. So, okay, so the total number of subarrays is 2 raised to the power n. Why 2 raised to the power n? Because uh, we can make two decisions for the element 1, we can make two decisions for the element 2, for element 3, and so on. So 2 into 2 into 2 for n times, it is 2 raised to the power n. So yeah, and our function should have printed 8 times because 2 raised to the power 3 is 8. So yes, we have 1, 2, 3, 4, 5, 6, 7, 8. So as of now, our function is pretty accurate and we don't have any problem with it. Okay, so what's next? One thing which I have to mention is that uh, here the elements are distinct. But what if not all the elements are distinct? Let's say, yeah. Now, as you can see, As you can see, the subsets 1, 2 and 1, 3. 1, 2 and 1, 2. Yeah, 1, 2 and 1, 3 and 1 are being duplicated. And why is it so? Because we can, take a decision of including the element at the zero index, which in this case is 1, and exclude 1 again, and include 2 and 3. So what will be the resultant subset? 1, 2 and 3. Now what if we exclude 1, we exclude the element at index 0 and include the element at index 1. So we'll again and include other elements as well. So the resultant subset will be 1, 2 and 3. Now this is just some extra work and we have to avoid it. Now you may ask how can we avoid it? So this most simple way of avoiding it is that hmm, how can we do it? So I guess um let me think, man. How shall we do this? Okay, I'm confused as well. Let me check first the constraints. Okay, the constraints are 0 to 1000. So 2 raised to the power 1000 is I guess more than the number of atoms in this universe. So it will take time. Yeah, it will take a lot of time. And we don't want that. So useful. Okay, I'm unable to think about um actually I did solve this question once, I guess. But I don't actually remember what I did. Okay, first of all, mm, okay, so one thing which I can think of is that if I'm excluding, let's say I'm excluding uh, index 0 and including index 1, then there's no point because it will just generate some duplicate elements. Hmm. Okay, so uh, let's just think of some other pruning methods or some other kind of pruning which you can do. Okay, so first of all, we can definitely say that, let's say, if the subset which we are creating, let's say, I want a bar of length, let's say 16, and I have included the elements 12, I've included the elements 12 and let's say 13. So what is the summation of 12 and 13? It is 25. And I have to make some more decisions. Yeah, I have, let's say, more 100 elements in my array, and I have to decide if I have to take some of the elements of this array or not. But is it necessary to, create an actual subset, complete subset, and reject it eventually? Because the length of the bars can't be negative. Yeah, the length of the bars can't be negative. So if the summation subset just becomes greater than the length of the bar which you have to create, then we can simply say that we don't want to create the subset anymore and we can simply reject it. And I guess we have saved some time by doing this. Okay, so first of all, we have to introduce instant sum. What does instant sum mean? Instant sum means summation of all elements in a subset. Yeah. What is happening? Yeah, instant sum. Okay, so do I have to actually create a variable for this? No, but I'm just doing this for the sake of it. Instant sum. Okay, so we are actually including the element at the index I and D. So we'll increment the instant sum by uh, ARR I and D, and as you can see, we are excluding it. Uh, so we are just going to subtract the ARR I and D which I have included earlier. Now let's say, okay, so we will add an extra condition if instance sum is equals to its target. Let's say we will introduce another variable target. Okay, target is actually unchanging, but yeah, we need it. And let's say target is equals to, let's say, 3 target. Yeah, if it is indeed equal to target, then only print the survive. Let's check, is there a subset which sums up to target 3? And yes, there is. There are actually multiple subsets. The element 3 itself, and by including elements 1 and 2. So let's check if uh, a function prints all the answers. Yeah, as you can see, there's a bit of duplication over there, but yeah, we'll dive deep into that. But one thing which we have made sure of is that we are actually solving the problem. Although these are this solution will not, it will TLE, it will TLE. But yeah, at least I got something. Okay, so what's the naive thing which we can do? One naive thing is, yeah, um, let me comment this out. Let's check if our problem is uh, passing data spaces. Yeah, so the first line consists of n. No, not n. N meaning, okay, target length. Let's call it target length. It's a more, sensical name of the variable. We will call this n, or the number of bars. Number of bars. Yeah. Include, then we'll create an array of length n, and yeah. Now, what's another thing we can do is bool, or we can just make this a global variable. Bool found answer is equals to false. Okay, so if instant sum is indeed equal to target, you know what? If instant sum is indeed equal to target, then we'll found answer will set found answer as true, and we'll simply return. If instant sum is greater than the target, then there's no point in moving forward, and we will just return. And yeah, and one more thing, If we actually found our answer, then again there's no point in moving forward. And it is written here as well. Yeah, generate, we'll call our function generate subsets. Okay, subset. System is target length and id is 0. Okay, if found answer, then we'll say yes. Yes, so we'll say yes, or we'll say no. Okay, and we'll set found answer as false again. Let's check if our solution passes all these test cases. No, yes, no, yes. And let's check um if this code or this solution is um you know fast enough to pass all the test cases without PLE. Yeah. Okay, I guess this is good. Not good enough, but yeah, I guess I'll get it easy and I'll be happy with that. Okay, I got an accepted. Why is it so? Hmm, this is interesting. Uh, oh my bad, my goodness, my bad. The okay, n doesn't represent the length of the length of the n doesn't represent the length of the array, but it actually represents the length of the bar which we try to make. And yeah, I guess we don't have to think in that detail about the duplicate elements and everything. I guess this code is just good enough because we're pruning in the right direction. So now, why did this code work? Let's say if we are not pruning at all. Let's say, okay, let's check if let's see if we are not pruning at all. Will it pass? Mm, I guess it will because p only p the number of summary ranges from 1 to 20, which is low, but I guess it should TLE. Okay, it didn't. This is interesting. Let's check. Now let's check the solution. Let's check the theory behind it. Okay, a bridged problem statement. Given a list L containing integers 1 to 20, is there a subset of list L that sums to another integer x? We can try all 2 raised to the power n subsets of integers, sum the selected integers for each subset in the Go of n, and see if the sum of the selected integer equals to x. The overall time complexity is thus n into 2 raised to the power n. For the last test case, n equal to 20, this is just 20 to 2 raised to the power 20, which is 21 million. And this is okay. This is large, but still viable. Okay, man. Okay, this is interesting. If you have never written an algorithm to generate all subsets for a set of numbers, see x is 1.2.3, task 8, okay, you must still be unsure how to proceed. An easy solution is to use the binary representation of integers from 1 to 2 raised to the power n minus 1. It describes all the possible subsets. If you're not familiar with bit manipulation techniques, C section. Okay. The solution can be written in simple C or C++ shown below, also works in Java. Since bit manipulation operations are very fast, the required 21 million operations for the last use case are still doable in under a second. A faster implementation is still possible. Okay. Oh, okay. This seems just pure brute force, isn't it? Um, yeah. And basically, okay, so there's another method of, not another method I can say, but what does 2 raised to the power n minus 1 mean? Okay, let's say if n is equals to 3. So 2 raised to the power n minus 1 is 8 minus 1, which is equal to 7. How can I actually represent 7 in binary? It is 1, 1, 1. And can you please list all the numbers from 0 to 7? It is 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, 1, 1, 101, 110, and triple one. Now, this actually represents, now we can say that 1 means the meaning of 1. A set bit means that we are actually including it in our subset. And by this logic, we are actually generating all the possible subsets. But one thing which is, yeah, we can also prove uh, in this method as well if some is, yeah, we can also prove it while with this method, but you know I will just use the recursive method and it's good to go as well. Shall I um mm, is it necessary to actually, I guess there's no need, I guess, uh, okay, so we'll create another um UA 12455 second solution. We'll try to solve the problems in as many ways as possible. It's just good. We will think in multiple dimensions instead of a single dimension. And yeah, bowl is possible. Let's say we will get a vector ARR. And yeah, so basically, what can be the values of, you get what I mean. The values are the value of num, which represents the substance. Let's say, yeah, we'll just call it I. We will not call it anything fancy. It ranges from 0 to 2 raised to the n minus 1. So 2 raised to the power n error size is n minus 1. Yeah. And I plus plus. And some initial sum is, and now we will iterate each and every bit. This is actually, this is big of n, and this loop is we go off to raised to the power n. We don't have to actually go through all this every time, but we have to. Now, okay, so the number of bits is, yeah, and okay, so if a given bit is set, then it means that it is indeed being included. So we'll say ARR check. Right, this is fine. If sum is equals to target, we have not and target. Yeah, we can also say if sum is greater than target break. Yeah, for pruning. Yeah. Mm, well, first check. I guess this is good to go, and if not, then return false. Let's try it for a sample test case. Let's say 1, 2, 3. Let's say our target is, let's say 2. Is possible. AR target. If it is true, then yes. If it's not, then no. Okay, one mistake which I have done frequently is that I don't put brackets in this ternary operator. Yeah, I have made this mistake multiple times, and I guess you shouldn't. So I'm sharing this with you. Yeah, fantastic. You are stuck. Yeah, my bad. We're not stuck actually. The file name is, yeah, it was wrong. Yeah. Yes, okay. What if I put in the one just three, just six? No, okay. Yeah. What? Okay, so we are making mistake over here. Mm, yes, let's just, for debugging, it's actually generating all the possibilities. No, no, it is not. It is not. Okay, so it is including only. Okay, let me check. Okay, so what does this null array or the null subset represent? It actually represents the number 0. What does 1 represent? It represents 1. What does 2 represent? It actually represents 2. What does 1, 2 represent? It actually represents 3. 1, 1, isn't it? What does 3 represent? It represents. It's 4, isn't it? It's 4, and that's it. That's the point when we have stopped our iteration. Let's say 1, 1, 1, 0, 1, 2. 1, 2, 4, 0, 1, 2, yeah. So what is the mistake? 1, 2, oh. Am I bugging over here? Okay, yeah. Actually, it was a backend issue. I guess it was, um, 2 raised to the power n minus 1. Not, yeah, you get what I mean. 2 raised to the power in bracket n minus 1. Not 2 raised to the power n minus 1. Yeah, that was a mistake, and I guess we are good to go. Um, Ideally, it should represent yes. Okay, so, and what about, let's say, any number higher than 6? Represents, yeah, great. So we'll submit this solution as well. Yeah, and uh, target len, int and vector in my bad. We'll take input for the array and is possible here target len. Mm, no, yes, no, yes. No, yes, no, yes. Okay, let's submit this approach as well. And actually, in this section, actually, when it discusses about brute force, how can we think in the brute force? Brute force are not always bad during the contests because we don't have to actually print the most optimal solution, isn't it? Because we are already in time pressure, and there's no point in uh, going through this during the contest. Yeah, it is actually useful to go through this while practicing the solution, but it doesn't in the contest. So yeah, that is the reason why we are trying to learn a brute force. Let's check. Okay, the stream is still on. I guess we are pretty much live. We are live for 42 minutes. Nice. Okay. Yeah. Second solution is vertical as well. Now we have solved the same question. Actually, the question is not about the bars. The question is about how to generate a bunch of subsets, or not a bunch of subsets, how to generate all the subsets possible. And yes, we have learned to do this in two different ways, using bit manipulation and using recursive functions. Let's go through this exercise 3.1.1. For the solution of UVA 725, why is it better to iterate through FGIH and not through ABCD? Okay, so I guess you don't have the reference for this question. Let's open this question. 7 to 5. Yeah, I guess let me check if my solution is good enough. I don't think I have submitted this question on virtual judge. Yeah, I haven't. Let me submit my solution and check if it works. Oh, presentation error. Fantastic. Let's just go to this question. Okay, so for reference, we are revisiting not for you. I'm revisiting this question again. I solved it yesterday, and it was a pretty interesting question. So write a program that finds and displays all pairs of five-digit numbers that between them use the digits 0 and 9 once, 0 through 9 once each, such that first number divided by the second is equal to an integer and where and um, where n is in the range 2 to 79. A, B, C, D, E upon F, G, I. If G, H, I, J is equals to n, where each letter represents a different digit, the first digit of one of the numerals is allowed to be 0. Yeah. Just a second, I'll come back in a second. Um, I'm audible. Just a second. Yes, I'm audible. Is my stream live? Yes. Let me plug in my laptop. Okay, so okay. Okay. Uh, I hope you understood the question. Okay, so let's say, let me make it clearer for you. That 10 digits. Okay, so out of all these 10 digits which are available, you have to use each and every digit from 0 to 9. You have to find a fraction such that the answer the result will be n. Okay, so this question is pretty interesting because how do we actually ensure that all the digits are what can I say um distinct, or that all these digits actually contain uh, or that both of the numbers, let's say numerator and denominator, and the numerator and denominator consist all the digits from 0 to 9. It is a bit challenging at first, but it is actually pretty easy. One naive thought which came across my mind while solving this question was that, try to bring each and every fraction possible. And I realized, like, within like 1 or 2 minutes. It's just stupid because what I was trying to think is that let's assume the denominator to be, let's say, 1. So what will be numerator n? Denominator, let's say this is. Okay. Actually, it is pretty close. We have to just share some of the we can just shave some of the searching which we will do in the approach which I just described right now. So basically, what's the smallest number we can get um, if we had decided to use all of the digits or all of the integers from 0 to 9. Okay, so we will take the far smallest digits, which is 0, 1, 2, 3, 4. So the smallest number possible which can be made using this is 34, yeah, 1234. And what is the maximum number possible which can be made using uh, all of these digits? So it is indeed 98765, which is 98,765. So actually, searching space is not that huge, basically. Okay, so how many iterations do we need actually to iterate from 1 to 3, 4, 1 to 3, 4, 5? No, not 1 to 3, 4, 1 to 3, 4 to 9 at 765. It is just, it is around 97,000, or we can say approximately 100,000, which is 1 lakh. So, can we afford 1 lakh iterations? I guess we can. It can be completed under a second, and we are good to go. And one more thing, do we actually have to iterate through all of these numbers? And the answer is not. Now, why? Now, one thing which we can do is, iterate through ABCD. Now, if we decide to iterate ABCD from 1, 2, 3, 4 to 9, 8, 7, 6, 5, then yes, we have to iterate through each and every possible value. But what if we iterate FGHIJ from 1 to 3, 4, 5, from 1 to 3, 4 to 9, 8, 7, 6, 5? Do we actually need to iterate till the end? And the answer is no, because um, okay, let's say I know I have the values of J H I J. So what will be ABCDE? ABCDE will simply be L into FGHIJ. FGHIJ, yeah. So the moment when numerator crosses the upper limit of 98765, we can just simply stop, because as the denominator increases, the numerator will also increase, and there's no point in checking because it's just out of the scope. So yeah, let's say if n is equals to 2. So roughly, what will be the answer? Okay, the answer will be 98,000 divided by 98,000 divided by 2. Let's say. So it will be approximately 50,000 for n is equals to 2, which is the this is the smallest possible value of n. So we are actually iterating from 1000 to 1234 to be precise till 50,000. And these are not a lot of iterations, but one thing is that we actually have to go through the all the digits which are in ABCD and FGHIJ. Now, what will be the number of uh, the number of iterations? It is 10. It is simply 10. I'm assuming that we all know um, how to go through all the digits of a number, but you know a decimal number. Sorry for that, I hit my mic. Okay, so what will be the total number of iterations for n equal to 2? It will be 50,000 into 10, which is around 5 lakh or 500,000. Um, yeah, and 500,000 iterations are pretty feasible. And one thing which we are going to do is that you may ask, how can we assure that all of these digits are included? Well, again, it's bit manipulation because bit manipulation is the fastest. Uh, bit manipulation is the fastest approach possible while trying to solve this problem because when we're working in terms of bits rather than in terms of array, we are actually pretty fast. So check out my solution. Mm, okay, so yeah. Okay, so FGHIJ will iterate only from 1 2 3 4 till 9765 divided by n, which is just a second. Yeah, and why is it so? Because if well, okay, yeah, I have just explained that the numerator shouldn't cross 9765 because there's no point in searching through that. Just a second, guys. Yeah, and yeah, in ABCD is FGHIJ into n, and we have to just calculate digits. Okay, so what does this digit represent? This digit represent, okay, imagine digits like in terms of uh, basically these are just bits, and we can use these bits to represent if a number is set. So by set, I mean that if a number is present in either of the um, FGHIJ or ABCD. Now, now you may ask why we have written this condition, because let's say FGHIJ is smaller than 10,000. Let's say 5674. Now, actually, there's a zero hidden over here, which and the number is actually 05674. But we are unable to uh, account for the zero uh, using a traditional approach of counting the digits and everything. So yeah, we are setting the zeroth bit if FGHIJ is smaller than 10,000, and let's check if what is the function count digits. Okay, the count digits is, first of all, we are iterating through each and every digit of num, and we are, let's say we encounter a digit 7. Now we have to mark 7 as present. So we are marking 7 as present as digits is equals to digits or 1 um, 2 raised to the power 7. Yeah. Now, what does this line mean? This line actually means that we are setting the bit 7 as set. We are setting the bit 7. Yeah, we're marking it as true. So you may ask, what will be the number at the end if all of the 10 digits are present? What I mean by that is, let's say 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All of these digits are 7. So what we will get is a number which is 111 for 10 times. Now what? Now in simple. Now we don't have to actually calculate this number to raise the power to raise the, you know what I mean. This number actually means 2 raised to the power 10 minus 1. If you have uh, gone through this bit manipulation tricks and everything, you know what I mean. And yes, we are checking if digits is indeed equal to 2 raised to the power 10 minus 1. If it is, then we are printing answer found. Then we are setting answer found is true, and we are printing the answer. Um, uh, Forgive my. I actually don't know if I can fill it with zero. No, I can't. I can't. Yeah. If let's say not ABCD, LGHIJ is smaller than 10,000, Then we'll print A0 first. Then we'll print EFGHISGHIJ. Yeah. ABCDE equals to N. Yeah, N. Okay. We'll print a new line, and I guess now we are. I guess now we are good to go. If there was a presentation error, let's check if the error has vanished. Okay, okay, my goodness. We are not actually compiling the right file. It is 7 to 5, UV 7 to 5. There are no solutions for 61? Yeah. Okay, okay. um, it's my fault. I'm actually printing the denominator upon numerator. Yeah, it's my fault. Let's just will print ABCDE as it is, and now we have to think about the denominator. Denominator is FGHIJ is smaller than 10,000. We'll print A0 first, then mm, and then we'll print the actual number, and then we can calmly say yeah. Yes. Okay, separate the output for two different lines of n by a blank line. I hope that this will work, and now we won't get an a presentation error. Uh, our logic is, I guess, solid, but the presentation error is actually messing with us. Okay, did I solve this? No, no, I didn't. Yeah. Okay, my bad. Okay, and what if are we getting presentation error because of this extra blank line? Mm, and in case number equal to 1, case number plus. And instead of printing a new line over here, we can print well, we can print we, we can print if case number is greater than 1, we can print a new line. Let's check. And UV is so jarring, to be honest, because of this presentation errors. Yeah, okay, so the new line is causing trouble, and as we can see, we have solved this question as well. Actually, I had solved this question. Yeah, for explaining this, why is it better to iterate through FGHIJ and not through ABC and not through ABCD? I guess this is a no-brainer, as I have explained the same thing now. Does it 10 factorial algorithm that permutes ABCD work for UVS 725? Okay, I actually don't know. What is the value of 10 factorial? So let's check. The value of 10 factorial is 36,28,800. Is this doable? I don't think so, man. I don't know actually. Okay. Time required for, let's say 3 million iterations in C++. Let's check. Actually, I don't know. Mhm. Depends. No, what I mean. Okay, I don't know that. I just wanted an approximate value. I guess it won't. I guess it won't. Let's just ask ChatGPT. Does it have the reference? Okay. Okay, so here's the reference. Mm, This is the question. Yeah. This is UVA 725. And yeah, this is the yeah, this is the exercise related to this question. So, what is the question? Does a 10 factorial algorithm help with this? I don't think it will. But let's check it. This is exactly kind of thinking. Okay. 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 What does 10? Yeah, these are 3.6 million permutations. Will it work? Yes, it will. It generates a valid arrangement, but it's a bad idea. It will. Okay. 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 That's interesting. Okay, I do know that it is indeed larger, but I was wondering if will it take more time considering the relevant candidates in the research and using the okay, don't explain the solution. Do you reckon uh, the permutations program will execute under a second? Surely yes, it will. Oh, it's not the right approach. Okay, small constant repeated coefficients. Okay, yes, should comfortably run under a second. Okay, okay, that's interesting. I didn't know that. Everything filter valid ones. Yeah, okay, generatively valid equations. Yeah, I guess it will, but is it feasible? No. ChatGPT is trying to explain the same like uh twice now. Java does not have a built-in next permutation function yet. If you're a Java user, write your own recursive backtracking routine to generate a permutation. So I guess we had done this. Um, the similar question to backtracking question for eight queens problem. Eight queens is actually n queens, which is a hard problem on I guess lead code. Yeah, I guess we have implemented a what is the permutation thing? Okay, permutation question is actually 11742 social constructs. 11742. Uh, okay, I guess it's in um in CP books. Oh my god, we had done the same mistake. I guess it's in chapter. We are indeed in chapter two. Oh. Mm-hmm. UV. Oh, fantastic. 117. Oh, I guess I solved this question. Let's check in my submissions. 11742. I guess I solved this question. I actually remember solving yesterday, I guess, not this one. This length. Hmm. I guess I haven't. Let me check. Mm, it's in programming and not CP book. CP book solving 11742. UA. Yeah, is it? Oh my god. We haven't solved this. I guess I have. Let me open it. 11742. I guess I'm bugging as of now. Yeah, I guess I'm bugging. I feel I have solved this question, but yeah, basically, we can indeed write not an experimentation function, but we can indeed generate all permutations which are possible, and yeah, it's not a big deal. Um, yeah. How would you solve UVA 12455? What is 12455? Okay, it is indeed the boss question. We are generating all the possible solutions of its it is because oh my god, it's a huge number. C section 8.2.4. Interesting. I guess let's just take a sneak peek at it. I don't think we will be able to understand it. Okay, 8.2.4. Meet in the bidirectional search. Okay, bidirectional search. Actually, I don't have any clue about this. 6 oh, fantastic. Chef's kiss. Okay, yeah, we will highlight this. I'll, I'll hope solve it again when we reach chapter 8. At this point, we're at chapter 3. Yeah, we're at chapter 3. Okay, recursive complete search. Simple backtracking UVA 8 queens chess problem. Yes. Yeah, we are live for that. Shall we mm, in Queen's problem, another in Queen's problem? I guess we're good to go as of now. And in tomorrow's string, we'll try, we'll learn recursive complete search. This is actually not that hard. It seems difficult initially, but trust me, it's not that hard. It will take some time. We will also read all the tips tomorrow. Yes. When will the questions start? The set of questions is optimizing your source code. Remarks. Okay, yes. Yeah. Yeah. Tomorrow will be a great day, I guess. Divide and conquer. We will not actually deep dive into it. Let's yeah. I guess we will not deep dive into dynamic programming as of now because we are in the early stages. And even though I know a bit of dynamic programming, not a bit of I know like I'm kind of good at dynamic programming. I'm kind of decent, but we'll first try to understand all the paradigms, which are the two important paradigms are greedy and divide and conquer. Divide and conquer is actually pretty important if you want a good code process ranking. I guess today, I guess we're good to go. We have solved two interesting questions. Too. I know this may seem easy as of now in hindsight, but upon seeing the question for the first time, I guess it will be difficult to solve. So yeah, I guess now we can end the live stream today. And yes, I hope you enjoyed it. It was only an hour. Tomorrow we'll stream for like 4 or 5 hours at least. So yeah, thank you.